Most beginners don't quit programming because it's too hard. They quit because they feel stuck. Not once, not twice, but every single time they try to solve a problem. And the worst part, they think it's their fault. You watch tutorials, everything makes sense. Variables, easy. Loops, got it. Functions, clear. But then you open a problem and suddenly nothing. Blank screen. Where do I start? What do I write first? Why does my brain just freeze? My name is Kamel. I've been working with code for over 2 decades, and I've seen this again and again that beginners don't struggle because coding is hard. They struggle because no one shows them how to think when solving problems. That's what we are fixing here. In the previous video, we talked about something important, that understanding code and creating code are two completely different modes of thinking. One is recognition. You see something and it feels familiar. The other is creation. There is nothing in front of you and you have to build the solution from scratch. And this is exactly where beginners get stuck because tutorials train you in recognition, but problems demand creation. Here's the truth. Understanding code is not the same as creating code. Watching is recognition. Solving is construction. And your brain treats them completely differently. There are three real reasons beginners get stuck. Not talent, not intelligence, just these three. 1. You don't know how to start. Most tutorials show you solutions, but they don't show you how to begin. So when you face a problem, your brain asks, what is step 1? And there is no answer. Let's take a simple example. Find the sum of numbers in a list. Beginner thinking, do I use a loop? Do I need a function? Where do I even start? A programmer thinks differently. They think start small. Number 2, you try to solve everything at once. You look at the whole problem and try to solve it in one shot. That's impossible. You remember the previous video? We talked about this. Good programmers don't solve problems, they break them. Number 3, you fear being wrong. This one is subtle. You don't type because you don't want to make mistakes, so you think more and type less. But programming is not thinking first, it's interacting. So, how do you break out of this? You don't need more tutorials, you need a different approach. We have 3 rules here. Start ugly. Don't aim for correct answer, aim for movement. Okay, for the example that we had, we take the first number and store it. Take the second number and add it to the first one, and then repeat the process again. That's the way that we go. It's messy, it's incomplete, but it moves you forward. We don't know exact actions, what commands we should use, and these kind of things, but it's okay. Rule 2, shrink the problem. So don't solve the whole thing, solve one tiny piece. So instead of sum a list, think, how do I add 2 numbers? For example, in Python or C++ or other languages. How do I repeat that? So you see, these are the different parts of the problem. Then we can combine them. Programming is stacking small certainties. And rule 3, use feedback, not perfection. Run the code early, even if it is wrong, especially if it is wrong. That's very important. Each error is information, not failure. And remember, in the previous video, we said something important. All programs, no matter how complex, are built from just a few types of actions. Even if you know those actions, you can still get stuck because the real problem is not the tools, it's how you use them. If this way of thinking helped you see programming differently, make sure to like the video and subscribe because this channel all about helping you Think like a programmer, not just memorize code. Let's continue with the second problem that we already discussed in the previous video. Finding the longest common prefix among some words. Beginner's reaction is, I know strings. I should use strings here. Maybe loops. Maybe I should use slicing, and already stuck. But here we want to apply the rules. First rule, start ugly. Let's not be smart. Let's just start. Should we compare words or we should compare letters? It seems that we should compare letters. We don't need the full solution, just the direction. We should be able to compare each letter from the same position in two words. We should be able to compare the first letter of two different words. And then we compare the second, third, fourth, and then continue like this. The other thing is that now we can see here, obviously, that when we reach to the end of one of the words, we don't need to continue the process. It's already finished. And the prefix cannot be more than that. Thinking ugly gives us this kind of broader image of the problem. Second rule. So the second rule is shrinking the problem. So now instead of just thinking about the whole process, we just try to focus on one of these tiny processes, which is comparing only two letters. And we need to find a way in our coding language to extract the letter from the word and compare it with another extracted letter from another word. And rule 3 is using feedback. We didn't guess the answer. We updated it step by step. So immediately we will try to find a way extract a letter from a specific position in a word. That's the way that we make our hands dirty. We didn't solve the problem. We reduced it. Let's try another one. Check if a number is a palindrome. You remember? Palindrome number is a number that from both sides we read it the same, like 121. Beginner's reaction is, do I use strings here or numbers? Do I reverse it? What's the trick? So they are thinking about the tricks that we need to use. But we are just applying the rules. So we start ugly. We need to compare the pairs of digits. No matter how we do it, at the end, we should be able to extract the digits from different parts of a number and compare them together. Rule 2 says that we need to shrink the problem. So my tiny problem here is the digit extraction from a specific position in this number. For example, I should be able to extract a digit from the fourth location of this number. Or I should be able to extract the fourth digit of this number or seventh digit of this number. That's it. That's my problem now, not the palindrome number. When I have this code in my hand, then I can start to think about comparing the first and last digit, the second and second last digit, and then continue, and then build up the repetition. And then in the rule 3, using the feedback, I need also think about that there are some stop conditions, that if I find any mismatch during this process, it is meaningless to continue. I should stop there because it's already not a palindrome number. Programming is not about doing everything. It's about knowing when to stop. Notice what happened In both problems, we didn't start with code. We started with the smallest steps, simple comparisons, and also feedback. This is the difference between understanding code and solving problems. Here's the shift that changes everything. Beginners try to write correct code. Programmers try to explore. Instead of asking, what's the correct solution? Ask, what's the smallest thing I can try? That one question is the difference between being stuck and moving forward. And if you want to actually practice this, you can join my community. We don't just watch code there. We solve problems together. We build thinking step by step, and we run weekly coding sessions. Now, let me give you something simple to hold on to. When you break a problem into steps, those steps usually fall into just a few types. In fact, all programs, no matter how complex, are built from just 4 types of actions. Do you remember them? Move forward, do the next step, choose, make a decision, jump forward, skip something, and jump backward, repeat something. That's it. Every loop you've seen, every condition, every piece of code comes from these. In the first video, we realized that something deeper happens in the coding. In previous video, we discussed that every programming problem can be broken into smaller pieces. And in this video, we talked about the reasons why we're stuck and how can we break this ice for programming. In the next video, we go deeper into this, what it really means to think like a programmer. I'll see you in the next video.